planning exercises. It's very much based, the Onuma system that we built is actually very much based on creating real-time BIM, real-time building information modeling, real-time energy data, to be able to make real-time decisions. And on the internet today, you can go to Expedia and make an airline reservation in real time. It gives you a bid saying, I'm going from Los Angeles to DC, here's the cost. You don't have to wait for 2 weeks for a report to come out and then circle the seat that you want. It also is kept very simple. The interface here, it doesn't ask you how much fuel would you like on the plane, or do you want the pilot's seat. And at Connectivity, we had heard a lot of discussions. We're not going to be able to solve all this complexity unless we have simple interfaces that the consumer can use easily. And the consumer, meaning even the building owner or the homeowner. And there's already tools on the internet that work like this. The reason the internet works is because you just log in and start working with whatever tools at hand. And that's very much about what we do as well. In looking at it from the BIM side, we're using our system, the Onuma system, as one of the tools and connecting to a lot of different types of applications through open standards. So at the simplest format, we can even start with an Excel file. So here's our interface here in the middle, but an Excel file could be a list of equipment saying here's 500 pieces of equipment for this building, and here are the spaces that they are in. And what does it look like? If you import that into our system, it actually creates a graphic saying here's the third floor of all the spaces. The bubbles are spaces, and inside those spaces could be furniture and equipment that also came from the Excel file. So the Excel file creates a graphic. Tying graphics to data is very powerful because you can start seeing patterns. It's just impossible to just look at lists and things all the time to be able to make decisions. Then the graphics also can say, well, what are the heating zones of the room, or which rooms are occupied. Color code the spaces that are occupied red and the ones that are not occupied green, or the ones that are above or below temperature. And these graphics right here. So the same data is generating graphics. The data generates graphics rather than creating graphics and attaching reports to it. The geographic information system aspect of it, everything has a latitude and longitude, so you can start placing these buildings on a site like this, and it has the right relationship as far as XY direction, XYZ direction, latitude and longitude. So it's a model server. It's a different concept of having access to BIM data in real time. We're not downloading a file and working with it. We're actually logging in and seeing that floor plan or seeing that report and editing it. It's a viewer, but you can also edit it. So if I had the right access level, I can grab a chair or a piece of equipment, move it out of the room, or move it to another room, or make the room bigger. And all those shifts that are happening are updating all the reports and all the links to whoever else has access in real time. BIMstorm, we've had close to 4,000 participants over the last couple of years. This is Penn State being involved in a 24-hour BIMstorm where we had participants designing and making decisions about this was for a city. It was 130 teams from around the world that had never worked together, using simple tools, designing 420 buildings in 24 hours, producing the equivalent of 2.8 million pages of documents that were never printed. In other words, you don't go to Expedia and print out every airline schedule. You work with the data that you want and you see it right there in real time. So they're seeing our server pushing into Google Earth. They're using their tools to do cost estimating and engineering input into the teams. This is one building of the 420 buildings. A very simplified view, but it's a 53-story tower. This is about a 30 or 40-minute exercise to create this graphic, basically the three-dimensional model saying it's 53 stories. It has 12 elevator cores. It has hotel rooms, 150 hotel rooms, and the upper floor is color-coded yellow. And we're thinking of using a structural system that's steel and a 14-foot floor-to-floor. Those key pieces of information drive cost, obviously, drive energy use. And in our server, we build this on our system, on our interface, and then we open it up to other systems that can do things like, well, let's look at in SketchUp, let's look at the curtain wall of the building. What's the exterior skin going to look like? In Ecotech, let's do an energy analysis. So other teams are pulling data from our server into their systems and doing Revit structural modeling work, AutoCAD MEP, designing the first version of an MEP system into the building, looking at furniture and equipment, life cycle costs from Whitestone Research. So these teams are then able to use their tool and then interact with us. We call this creating the train wrecks. We want to see how much interaction can we have at this early stage of design to make these design decisions for a new building, or it could be an existing building too. If you imagine this as an existing building, it's the same concept. If we have access to information, we can start having a dialogue about how energy